So today we would be discussing what is normalization. So normalization is something that we use for data cleaning, for refinement of data, so that the data is very much useful for analysis and it is very much visible. There are no anomalies in the data. There are no errors in the data while we insert, update, or load the data. There are no duplicate values in the data. For that, the process that we use is called normalization. So the data, when we get the data from any organization or anywhere, any of the platforms, let's say Google, or we download it from an open source database, that data is completely in a raw form. So that data needs to be refined so that we can perform analysis on data. So this is a small, not a small, but a huge topic and a huge presentation as well that I would be starting today. I don't know whether I would be able to complete it in 1 hour or not, because it's an important topic, though it is not used in the industry while you are running queries and performing your tasks on a database. But yes, as one of you has asked me to work on normalization, so here I am with this presentation on normalization. Will be this presentation has a lot of examples also. Just hold on, guys. I have a call to take. Just muting. Hello. हेलो. हाँ ना, मेरा एस एस एल पीकॉक के अंदर मैंने 2 प्लॉट खरीद रखा है. मुझे उसका पास 3 मंथ से 4000 रुपीज़ आया नहीं है. 879A 879B. मेरा वाइफ है, उन वो आपसे बहुत बार बात कर चुके हैं, बट अभी तक ना जुलाई, अगस्त, सितंबर एंड हो रहा है, 3 मंथ्स का अभी तक पैसा नहीं आया है. आप नोट कर लीजिए प्लॉट नंबर 879A 879B. रक्षिता नाथ, अवन सेठ, 2 लोगों के नाम पे 2 प्लॉट्स हैं. हाँ ना. ठीक है, मैं इस मंथ एंड तक वेट करता हूँ आपका. ओके ना, थैंक यू. I'm sorry, guys. It was an important call from office. I had to take it. Okay, so let me see who all are there on the call. Okay, Abhishek is also here. Fine. So as I mentioned, it's a topic that is required for your knowledge, but it is not something that you would be using normalization in your day-to-day industry work. So let's start with it. So we have the major objective for normalization is basically it is used to create a framework on which uh, you can conduct your analysis. The database should look very much clear and without any errors. That is the main task of normalization. So we have different normal forms. We start with the first normal form, which is called 1NF. Then comes the second normal form, third normal form. So we have this thing. We have first normal form. We have second normal form. Sorry. We have third normal form. We have fourth normal form, and we have fifth normal form. In all these normal forms, the first task is to eliminate the repeating groups. How do we do that? So I'm taking you step by step. Till whatever level we'll be able to complete conveniently, we'll work out on that. So before understanding any of the normal forms, how we proceed forward, we should need to understand what is a functional dependence. So functional dependence is an association between two attributes. So try to understand what are attributes. Attributes are something which are columns of the table. So functional dependency is an association between two attributes of a same table. One of the attributes is called determinant and the other attribute is called determined. So determinant is something which is an element which will help you identify the other attribute, and the other attribute which is being identified by this attribute is called the determined. So that element, let's say serial number is one of the attributes. Serial S name or the serial name is the another attribute. This is the third attribute and this is the fourth attribute. So when I say that one attribute is able to identify the other attribute, so this is my determinant, and this is the one which is being determined from serial number. So this will become determined. So that is what the definition of a determinant and a determined is, or a determined element or an attribute is. So a dependency diagram consists of all attribute names and all function dependencies in a given table. So let's say a table has these values: serial number, serial name, city, and status. So serial number, from one element, from serial number I can determine city, I can determine the status, I can determine status name. So city, status, and status name or serial name, they are dependent on serial number. So the terminology or the way we mention a determinant and a determined is given by an arrow between two elements. So serial number can be used to determine serial name. So this one, serial number, can be used to identify serial name. Serial name can be used to identify serial number. Serial number identifies city. Serial number identifies status or determines status. So in this way, this is how functional dependency is defined as. I'll explain you again. With the definition, if A is a determinant and B is determined, let's say A is serial number, and B is city. So A is determinant and B is determined. Then we say that A functionally determines B, and graphically it is represented as A with an arrow B. This can also be expressed as B is functionally determined by A. So either ways it works. So that is what a functional dependency is. I'll let you know where it would be used. So it is something from which you are identifying another attribute by using one attribute. That is called a functional dependency. An attribute is functionally dependent on another attribute. So an attribute helps to identify, helps to find out, helps to determine the other attribute in a table. That is called functional dependence between two attributes. So there is another term which is called fully functional dependent. So when it comes to fully functional dependent, it means, I'll explain you. Fully functional dependence is defined as when attribute Y is fully functionally dependent on attribute X if it is functional dependent on X and not functionally dependent on any subset of X. So what does it mean? Like, now serial number, let's say city, or rather let me take serial name. So city is dependent on serial number. There is a link between serial number and city, but there is a link between serial name and city as well. So city is just not functionally dependent on serial number or serial name. So that's why we say that it is not fully functional dependent on serial number, because city has dependence on serial name as well or status name as well. If city would be just identified by serial number, then this relationship between serial number and city would have been fully functional dependent. So for example, in a relation supplier, different cities may have same status. Just ignore this part. Just ignore this thing. So for example, different cities may have same status. It may be possible that cities like Amritsar, Jalandhar may have the same status as 10. So two cities like let's say Vijayawada and Hyderabad, they are given the same status as 10. Then city is not fully functionally dependent, is not functionally dependent on status, but the combination of when I mentioned when I mentioned city is dependent on serial number, city is dependent on status name. So city is completely dependent on combination of serial number and serial name and status name. So it's a composite dependence. It's not a fully dependence on a single attribute. But the combination of serial number and status can give only one corresponding city because serial number is unique. So it could happen this way. If I show you a table, let me just pull out a sheet. So these things are important to understand how first normal form, second normal form, and then third and fourth normal form function. So that's why I'm laying a little stress on this thing. So let's pull up a sheet. So let's say I'll zoom in. So let's say I have serial number. I have status name, I have city. So let's say serial number 1, Amritsar, status code 10, Amritsar. Now serial number 2, or let's say 11, and I have say Hyderabad, let's say Pune, Mumbai. So 10, 11, 3 and 4. See, status 10 indicates S name 10 indicates Amritsar. 10 also indicates Pune. But what's the differentiating factor? A combination 1 and 10, 3, 10, these are unique. They are not repetitive. There won't be any 1 or 10 ahead. I can't see any combination of 1 and 10 ahead in this table. So when a combination of two attributes determines the third attribute, so what do we say? Serial number, S name, they identify city. So they identify a city. From here, they identify a city. The combination of these two is identifying a city. I am not denying that fact that there is a relationship between S name and city as well, because 10 represents Amritsar, 10 represents Pune. But this is not fully functional dependent, because there is some serial number associated with every S name. There is some serial number associated. So in that case, when an attribute is dependent on multiple attributes, where I cannot say that only a single attribute, where I cannot say that okay, serial number is unique and from here I can define a city. When it is not possible to say that thing, it means that city is not fully functional dependent. It is functionally dependent on a group. It has a functional dependence on a group. How? So the combination of serial number can give only serial number and status can give only one corresponding city, because serial number is unique and status keeps on repeating. So it means that city is functional dependent on the combination, which is serial name and status. However, city is not fully functional dependent on this composite attribute. That's what I mentioned, that there is no fully functional dependence. There is only functional dependence. So just keep these two things in mind, that what is functional dependence and what is fully functional dependence. Now we move on to first normal form, in which Functional dependence and fully functional dependence will come into picture, but as of now, keep those things on hold. I'll explain you how these things are. Now, for first normal form, the only step in the first normal form is, suppose you have this table, you have this data, you got this data from somewhere or the other, some website or some database. This is student data that has course code, that has course name. You have a teacher name, roll number of the student, name of the student, system that a student has been assigned to is working on, hourly rates, and total hours. So let's say for Pentium 1, it has been decided that for 20 hours, the charges would be as per 20 rupees per hour. This is that hourly rate. So 20 rupees per hour. And then total hours to calculate the total amount. So 20 into 7, that's how the total charges would be calculated for a particular student who would be using a particular system or a particular machine, Pentium 1, Pentium 4, P1, P2, P3, P4. They are just for the understanding. Now, the first step in the first normal form is to fill in all the repetitive values. See, over here C1, so this is like C1 Visual Basic ABC, A1, A2, A3, A4, A1, A2, A3, A4. These all are reading C1 Visual Basic from the teacher, C1 Visual Basic from ABC, C1 Visual Basic from ABC teacher. So the first step in first normal form to get the table into first normal form is to fill in all these gaps. You have to fill in all these repetitive values that are present, that are not mentioned in the table. It could be anywhere. It could be over here as well, in the system as well. If certain things are repetitive, they had not mentioned it, then from your understanding, you have to fill those values. So the first approach is flattening of the table. That removes the repetiting groups by filling in the missing entries of each incomplete row of the table with copies of the corresponding non-repeating attributes. The following example illustrates this. So this is the example. It mentions filling in the missing entries of each incomplete row of the table with the copies of their corresponding non-repeating attributes. So filling in all the repetitive entries which are over here, these are the repetitive entries that need to be filled, and these ones are non-repetitive. These are not repeating for C1. These are different. 100, 101, 102, 103, A1, A2, A3, A4. These are different for these missing entries. So this section is what it is referring to, non-repetitive attributes, and this section is something that text is referring to, repetitive attributes. So missing entries with the incomplete rows of each table with copies of the corresponding non-repetitive attributes. The next slide will show you how we do that. So we just filled in these missing values over here, and over here. Only these missing values have been filled. Now the second step comes. This is the first step to be done for the first normal form, for the first step of normalization. The second approach is decomposition of the table. Now, if you see over here, let's say I have to introduce another student, say roll number 200, some student roll number 200 with name A4, A5, something, A11. Then he studies, let's say, course C1, he studies course C2, he studies course C3 and C4 as well. He studies every course. I'll have to enter the name, number, the roll number, the name, the system use, hourly rate, total hours, the course name, the course code, and the teacher name repetitively in this table, because there are multiple entries in the table. There are repetitions. There are a lot of repetitions in the table. There are multiple entries of the same thing. So if I need to add a new record, it would be a hassle for me. I would be making that entry all over in the table again and again, so that my table is complete. To avoid that, we decompose the table. What we mean by decomposition is dividing the table. So the second approach for normalizing a table requires that the table is decomposed into two new tables. The first step after the first step in second approach is divide the table into two new tables that will replace the original table. How do we do that? So before decomposing the table, we need to identify an attribute or a set of attributes that can be used as table identifiers, like the primary key. The table identifiers from which other values in the table can be identified. So the rule for decomposition is one of the two tables contains the table identifier of the original table and all the non-repeating attributes. So we are one thing is sure, we have to divide the table into two parts. I'll explain it to you in a better way over here. Okay. So this is my table. I have to divide this table into two separate tables, and the second step is I have to divide these tables on the basis of some table identifiers on which I can identify elements or attributes in the table. Over here, if you see, now let's say what is a possible thing that you see over here. So course 1 Visual Basic and the teacher is ABC. So Visual Basic and the course 1 Visual Basic is course 1 and it is taught by teacher whose name is ABC. Oracle and Development is the course 2 taught by DEF. C3 is taught by KJP and the course name is Java. So, or C++. So, what we can do is we can create a new table where we have C1, course code, course name and the teacher. Right. So, on that front, one table. So, course code is a common identifier for a student to understand what student is studying which course. Let's say I create a new table. Why is it not working? I have to stop this. Yeah. Let's say I create a new table. One would be course code, course name and teacher name. So I will have just these entries: C1, C2, C3, C4, teacher name ABC, DEF, KJP and Kumar. So he teaches Java, teaches C++, you have Visual Basic, Oracle and Development, and you have Visual Basic. So I create this another table from this table. Now, but I need one table has been created based on this identifier, which is course code, because this course code helps me identify course name and helps me identify which teacher that course would be taught. But what about the remaining attributes? What about the second table that we need to create? In that case, what does a student do in college or in a university? He just studies a course, that's it. So we can have another table mentioning course code. So this is the identifier that I have picked up, which is course code. On this identifier, one set would be with the elements which are repeating in the table that I have created over here. So C1 Visual Basic, C2 Visual Dev, C++, all these are repetitive ones. So I picked up the repetitive ones and tagged them with the course code and created another table, and remaining all the non-repetitive elements will come over here with course code, which is a table identifier. So name, system used, we have hourly rate, we have total hours. So this would be my second table. What this says now, one of the two tables contain table identifier of the original table and all non-repeating attributes. The other table contains copy of table identifier and all the repeating attributes. So I have table identifier with all the non-repetitive attributes. I have this table identifier with all the repetitive attributes. Now the general question comes like, how do I identify a table identifier from a database? That is from your knowledge, from your understanding of the database, your understanding of the data that you have in front of you. So the course code, see, roll number is also a unique element, course code is also a unique element, but on basis of which element I can identify all the other rows in the table, all the other columns in the table, which is the common element from which I can identify all the other elements in the table. From course code I can get to know what is course name, what is teacher. From a roll number I can just get the details of a student, his name, the system being used, the hourly rate and the total hours of system being used. But how to link a student with a course? So that would be a course code. So course code is a table identifier. That's how we identify a table, based on the knowledge of the database on which we are working on. Let's see what these guys have done. So they have divided a table into two parts. One is a course table. That's what we also created. We have a course table and we have a course student table. So a course table which has course code and all the repetitive elements in the table, and course student table where we have course code and all the non-repeating attributes in the table. This is the completion of first normal form. So to summarize everything for first normal form, first step is we need to fill the table with all the missing values, which are the repeating values, all the missing rows in the table. So all the missing rows in the tables need to be filled up. Once they are filled up, we get the table like this. The first step is filling the table with all the missing values. Second step of first normal form is you have to decompose the table into subtables, into two tables. So the approach for dividing the table is, first you identify a table identifier, pick that table identifier, assign all the repetitive attributes, the attributes that are repeating with that table identifier, and create a table. Pick the table identifier and pick all the non-repeative attributes and create another table. See, to normalize the student table, we need to replace it by two new tables. The first table is the course, that contains the table identifier and the non-repeating groups. These attributes are course code, which is a table identifier, course name and the course teacher. Then second table contains the table identifier and all the repeating groups. Therefore the attributes of the course student table are course code, this would be non-repeating groups and this would be the repeating groups. There is some error, I'll edit it. So this is how we create a table. Understand my point? Any doubts in first normal form before we go ahead and check out the second normal form? Any doubts you guys have in the first normal form?
No.
Ganesh, Uday, Rushmita?
No, sir. No, sir.
Okay. So we come to second normal form. Second normal form, the first condition to convert a data table or convert a database into a second normal form is that it should be in first normal form. So we need to go step by step. First we need to convert it into first normal form. Before that we can't convert the table into second normal form. So a relation R is said to be in second normal form if and only if it is in the first normal form and every non-key attribute is fully functional dependent on the primary key. That's why I explained you what is fully functional dependence and what is functional dependence. So this is what we discussed over here. So when I have when an element when an attribute is dependent on two different attributes, it is functional dependent on the combination of those attributes. It is not fully functional dependent. For an attribute to be fully functional dependent on another attribute, then it should be like, let's say, status and city. So, or rather, we take our example only, what we were discussing. So, over here, course name and teacher name individually are fully functional dependent on the course code. How? When I say Visual Basic, what is the course code associated to it? C1. What does Kumar sir teach? Course C4, which is Java. So if I say Java, I say C4. If I say Kumar and I just have the course code, I can identify the course name and the teacher name only if I have the course code. So course name is dependent on course code and teacher name is also dependent on course code. That's what it says. Every non-key attribute is fully functional dependent on the primary key. So course code over here is a table identifier, which is a primary key over here because it is not repetitive and it is not null as well. So these are non-key attributes. This is a key attribute, primary key. So course name, when it comes to course name and table and teacher name, they are non-key attributes and these are identified by the primary key course code. So this table is in first normal form as well as in the second normal form because it satisfies both the conditions of a table to be into second normal form. A relation R is in second normal form or a table is in second normal form if and only if it is in first normal form and every non-key attribute is fully functional dependent on the primary key. The resultant database of the first normal form course code does not satisfy the above rule. So, let me see. Course code does not satisfy the above rule because non-key attributes like name, so it is talking about this table, this entire table. It is talking about from the very beginning, this entire table. So, where were we? Name, system used, and hourly rate are not fully dependent on the primary key, which is course code and roll number. Over here, if you see, C1 Visual Basic ABC, these are repetitive. C2 Oracle, these are repetitive. But if I say a combination of course code and roll number, C1 and 100 won't be repeated anywhere. Understand? Because course code and roll number both are unique and they both combined form a candidate key. I have already explained you all these things, what is candidate, primary key, foreign key, everything. So course code and roll number, when they combine together, they can easily identify the name, the course, which teacher, system used, hourly rate and total hours as well. Let's go back to what we were reading. The resultant database of the first normal form course code does not satisfy the above rule because non-key attributes name, system use and hourly rate are fully dependent on the primary key, which is course code and roll number, because name, system used, hourly rate are functional dependent on roll number. How? Name is definitely dependent on roll number. I cannot say roll number course C1 helps me identify name A1. No. When I say roll number 100, it mentions oven or A1. So roll number is the unique identity for the name A1. So A1 is functionally dependent on roll number. Now system used. For a particular roll number, there is only one system that is assigned. See, for roll number 100 it is Pentium, 101 Pentium 2, 102 Celeron, 103 Pentium 4, 100 again Pentium 1. This is Pentium 1, this is P1. This is the same thing. Just they have mentioned it in a full form, which should not have happened. That's an error. But consider it. This is Pentium 1 and P1 both are same. 104 Pentium 3, 107 Pentium 2, 101 Pentium 2. 101 over here was Pentium 2. 101 over here is again Pentium 2. 107 was Pentium 2. 107 has changed to Pentium 4. But every student has a system assigned to him or her. So when I say roll number, when I want to understand Pentium 1 is assigned to which student, so I say, let's say Pentium 4 is assigned to which student. So I say roll number 100, roll number 106, and now Pentium 4, so roll number 107. So it is also dependent on roll number. Now hourly rate. I need to identify student roll number 100. How many hours did he work? So that would come from roll number. So hourly rate is also dependent on roll number. I won't say I don't have a tracking mechanism to understand Pentium 4 has been used for how many hours. But if I have a table, if I have a register maintained, whenever you go to an internet cafe, so they take your ID card or they give you a system number. Let's say system 1. So that's a roll number 1, kind of. System 1 is assigned to you. Once they note down the time when you enter and they note down the log off time when you switch off your system. So on that basis, on that system 1, they find out how many hours the system 1 has been used. So from roll number 100 only I can find out that this student has worked for how many hours. So hourly rate is also dependent on roll number. Total hours in turn, it's derived from hourly rate. So total hours a student has worked on a particular system again depends on a roll number. I won't check out which system has Pentium 1 and then go back to the system logs and check out, okay, this system was on for 7 hours. I would check this student with roll number 100 came in. I have assigned him Pentium 1 or system number 1. Once he logs off, I get to know these are the hourly rates and this is the total hours he has worked on. Understand? So Pentium 1, so if you see over here, Pentium 4, the hourly rate is 40. For Pentium 1, the hourly rate is 20. Pentium 3, the hourly rate is 30. This is fixed over here. For Pentium 2, hourly rate is fixed. But to understand which student has been assigned, how many hours a student has worked, so you need to calculate that time because all these things are dependent on the roll number. So, name system
and also, if you go back to the page, the student with the same, the student who is working on the system Pentium 1, that student is running the same course again on Oracle development as well, which is the same Pentium 1. The system is assigned to that same student.
Yeah.
So when we calculate the hours, normally it will calculate for all the
courses
systems. Yeah, is that correct?
Yeah.
Thank you.
So roll number, they what I mentioned, name, system use and hourly rate, they are functionally dependent on roll number, and roll number is a subset of the primary key. This is my primary key because these combination of these two helps me identify all other elements in the table. But name, system used, hourly rate and total hours, they are dependent on roll number. So it's a subset. Roll number is a subset of the primary key, so it does not hold the law of fully functional dependence. What does fully functional dependence means? It should be fully dependent on one attribute only, not the combined one. If I say city is completely identified by serial number, then that shows there is fully functional dependence between serial number and city. Now, course code and roll number, they help to identify every element of the table. If I say C1 roll number 100, which system did you use? Pentium 1. There is another C100? No. Let's say 107. So C2 107. Which system did he use? P2. What course he is studying? Oracle Dev. What is the teacher name? DEF. So what's the student name? Again. So C3. So course 107 and C3. So the combination of these two helps to identify all others, but only these four, name, system used, hourly rate, total hours, they are dependent individually on the roll number, which is the subset of the primary key, which is course code and the roll number. So in order to convert the course code database into second normal form, following rule is used. So what the rule says? Let's not get into this. I'll let you know. So this is what the rule says. It says, so A and B, this is serial number and your course code. Sorry, roll number and course code. These two things help you identify third element, which is C. What is C? Course code, roll number helps me identify course name and teacher name. Fine, that works. But this combined thing helps me identify name, system used, hourly rate and total hours as well, which becomes my set D. Because these sets, these four things are completely different from course name and teacher name. There is no link. I need not to understand Pentium 4 worked on Visual Basic or Oracle Dev or C++ or Java. So teacher name, course name are completely different from name, student, hourly rate, and name, student, hourly rate and total hours are dependent on the student. Student is linked to roll number. So what we do is, when let's say this is my roll number, this is my course code, this is my course and teacher name, and this is remaining all name, system used and hourly rate and total hours. Now you see that course code and table name are identified by A and B. A and B also help you identify these parts, name, system and hourly rate and total hours. What we do is, in second normal form, we divide it into two set of tables further. So one set would be with one attribute and another set would be with other attributes. So roll number identifies my D and roll number course code helps me identify the course name and table name. So this is already this table we had already created in first normal form: course code, course name and teacher name. You understand? What we are working is the remaining set, which was which was this one: course code, roll number, name, system used, hourly rate, and total hours. Course code and roll number helps me identify teacher name, course code, fine. So I have separated course code and created a table. This was created in first normal form, 1NF. Both of these are created in 1NF. But this table still has some problems that need to be modified. So what it does is, actually the slides are a little bit over and above and they are not arranged in a proper manner, that's why. So focus on this table: course code, roll number, name, student, system used, hourly rate, and total hours. Now course code and roll number are a primary key. So I'll again mention it in an easier way. This is my roll number, this is my course code, So again, this is my roll number, this is my course code. From ऊपर वाला table, from course code and roll number, if I know course code and roll number, I can derive total hours easily. Understand this point. A student 100 worked for total 7 hours. On which course? Course 1. Hourly rate is a different thing. Hourly rate depends on which system it has been used. For Pentium 1, the hourly rate is 20. For Pentium 2, hourly rate is 30. See, for Pentium 1, the hourly rate is not changing. For Pentium 1, hourly rate is 20. For Pentium 1, the hourly rate is 20. Here also it is 20. First row it is also 20. For Pentium 2, it is 30. For Pentium 2, it is 30. For Pentium 4, it is 40. For Pentium 4, it is 40. Here also it is 40. For Celeron, it is 10. For Cyrix, it's 20. So, hourly rate and system used, they are dependent on each other. They cannot be separated. But from this table, when I need to decompose, I have to again put it into first normal form. So, I have repeated courses, I have roll number, I have these things. How I can separate this? So course code and roll number becomes my table identifier. Again, I'll put it in first normal form. Course code and roll number becomes my table identifier. So I pick up C107 as like my table 1. Course code, roll number, and total hours as the table 1. And the next table, so roll number, course code, and total hours. This is total hours. This is remaining all, which has name, system, and rate. So name, system, and rate are dependent on roll number, like what we discussed over here, that roll number is a subset of the primary key, and name, system use, and hourly rate are dependent on roll number. So name, system rate, and rate are dependent on A only. That's why I have an arrow starting from A. Right? So what we do is we divide the table into A, B with C, which has total hours. This one. This is one table. And this becomes my second table. So this is what we got in first normal form. We have divided into further the second table into two parts. One is course code, roll number, and total hours, which is A, B, and C. Then this is the D part: name, student used, and hourly rate. This is the D part with A in it, roll number. So the rule to convert first normal form to second normal form. Consider a relation where primary key consists of attributes A and B. These two attributes determine all other attributes. So roll number and course code helps to determine all other attributes. C is fully dependent on the key. Total hours, it's completely dependent on course code and roll number. If I need to find out which roll number studied which worked for how many hours on which course, so course code and roll number, total hours are dependent on roll number and course code. Now, attribute D is partially dependent on the key because we only need attribute A to functionally determine it. Name, system used, and hourly rate. These all are dependent only on roll number. These all are dependent only on roll number. A, on attribute A. D is partially dependent on the key because we only need attribute A to functionally determine it. Attributes C and D are non-prime and non-key attributes. Very true. This is attribute C, total hours. This is C, D, 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 A and B. Or either ways, you can put A or B anyways. So, what does it say? Attributes C and D are non-prime, right? They are not the prime keys. C and D are not the prime keys of the table. The rule is to replace the original relation by the two new relations. So that's what we did. The first new relation has three attributes A, B and C. Primary key of this relation is AB, which is A, B and C. So course code and roll number become the primary key of course code and the total hours table. The second relation has A and D as it has only two attributes. So we create the second table which is with A and the attribute D. So A would be the primary key of this table of the second relation, and that attribute D is now fully functional dependent on the key. How it is fully functional dependent? So these are attributes D, what we studied. This is D, this is D, this is D, this is the attribute C, this is B, this is A, this is A over here. So for every name there is one roll number. It is fully dependent. A roll number is assigned a particular system, so it is fully dependent. A system is linked to hourly rate and these two are linked to roll number only. So all these elements can be identified only one group, one attribute which is roll number. There are no two attributes. Only one attribute is there which is roll number on which these are dependent. That makes it fully functional. That's what we saw in this Excel. If city is dependent only on single of these, then it is fully functional dependent. If it is dependent on both of these combined and without each of these independently city can't be determined, then it is fully dependent, functional dependent, not fully functional, just functional dependent. Over here, name, system use and hourly rate are fully functional dependent on roll number. This is how second normal form works, but still the second normal form is not a clean form of our data. Relations in 2NF are still subject to data anomalies. Data anomalies means there are errors that can happen while working on this data set. Which data set? This data set. While working on these three tables, we can have some anomalies, some errors, some issues while working on this database. For sake of explanation, let us assume that the system on which a student works functionally determines the hourly rate. Good. So, system on which a student is working determines the hourly rate. So, system used and hourly rate are linked to it. That's what I have mentioned to you. For the sake of explanation, let us assume that the system on which a student works functionally determines the hourly rate charged from that student. That is, system used is functional dependent on hourly rate. The fact was not considered in the explanation of the previous normal form, but it is now an unrealistic situation. How? There would be insertion anomaly. If I need to add a new value to the table, to this system student system charge table. We are just focusing on this table right now. Student system charge table. So try to understand. For example, consider a situation where we would like to set in advance the hourly rate to be charged for the students for a particular system. Let's say there comes up Intel 5 or quad core or dual core, what we are using these days, or let's say a MacBook comes into picture as a system. I need to define its hourly rate. Will I be able to add just the system and hourly rate into this table? Just answer me. That's a question to you. If I need to add MacBook for 10 hours per hour, 10 rupees per hour, how will I be able to add a MacBook over here? Is it possible to add this row in this table? I'm asking you guys, is it possible to add this row in this table?
Yes, you can add that.
How?
Because not able to put it out from my mouth.
Others, please answer. Can we add this row in this table?
Yes, I'm so sure that we can add a table in this row. We can add a row in this table.
No, you can't add this row in this table. If I'm adding this row in this table, my primary key would become empty. I don't have a student who would be working on
But you are
math.
giving a roll number to that.
I didn't say I'm adding a roll number to it. I said I have a new system in my lab, in my computer lab, that has MacBook, that for which the hourly rate is fixed at 10 rupees per hour.
No, that if that's the case, we can't add to it. I'm sorry, my bad. No, I'm on the picture.
We can't add this new value to this table because my roll number field would become empty. And roll number is the primary key of this table, and primary key cannot be null. So what I was discussing is we are not able to add another value of system use or hourly rate into this
आपकी
table.
आवाज नहीं आ रही है.
आवाज नहीं आ रही है. Hello, 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 hello. Okay.
No, you're not audible.
Hold on. Hello. Yeah. So,
Yeah.
what we were discussing was if a situation. Okay, some person Ganesh has joined as a guest. Yeah. Thanks for adding in. So, I cannot add another row as MacBook with a rate of 10 rupees per hour in this table. Abhishek, please go on mute. Please go on mute, guys. So I cannot add a MacBook with an hourly rate of 10 rupees in this table because it is dependent on the primary key and I cannot have a primary key vacant over here. So that's an insertion error, an insertion anomaly that I would face over here. See, it says, consider a situation where we would like to set in advance the rate to be charged from the students for a particular system. We cannot insert this information until there is a student assigned to that type of system. So, where were we? Yeah. Unless until there is a roll number, a student name assigned to MacBook or Mac operating system or Macintosh, I cannot add this value in this table. So my database, my table is not that much robust to handle certain things which are dependent on each other. System use is dependent on hourly rate. I can fix an hourly rate for a particular system. I cannot fix an hourly rate for a student. I cannot say roll number 100 ka hourly rate is 20 rupees per hour. No. I can say my Macintosh can support because I have to get the cost from my operating system, my investment in operating system. I have invested lakhs of rupees in my computer lab and I am taking money on hourly basis, but I can't designate that thing on a student. That varies from system to system, from one operating system to another, from Linux, Windows, Macintosh, it varies. So I cannot add this row in this table. So notice that the rate that is charged from a student for a particular system is independent of whether or not a student uses the system or not. So actually, system used and the hourly rate charged for that system is completely independent of the student who is using that system. Understand? A MacBook charged for rupees 10 per hour, this thing is completely independent whether a student is assigned to it or not. But in this table, we cannot add that value. So that is a problem with this table. In an ideal situation, system use and hourly rate should be independent. It should not be linked to any student or any person who is using it. If you go to an internet cafe, they won't decide that, okay, Avin has come, so we'll charge him 20 rupees per hour. Abhishek has come, we'll charge him 40 rupees per hour. Okay, Rushmita has come, we'll charge her 10 rupees per hour. It doesn't work that way. So every system and the hourly rates are independent of any person who is working on it. That is a problem with this second normal form from which we have got this student system charge table.
Like for example, in a company, a pay cycle is designed on the designation but not on the name.
Yeah, right, correct. So very much correct, Abhishek. That is another example to understand things from. So a manager would be getting a particular set of salary based on his designation and based on the task that he has been assigned to, primarily on the designation. An analyst or a junior manager or a consultant won't be getting the same salary. So it doesn't matter whether Abhishek is getting 15 lakhs. It matters Abhishek as a manager getting 15 lakhs. So manager decides the salary, not Abhishek as a person. The salary is decided on the basis of. So another anomaly that comes is update. Update anomalies will occur in the student system charge relation. Update is when I'm updating the table, because there may be several students which are working on the same type of system. See, I have this Pentium 4 over here. So a student 103, student 106, student 107. So a student 103, 106, 107. They all are working on Pentium 4. They all are working on Pentium 4. So, what if I need to update this table? And the condition is if the hourly rate of a particular system changes. Let's say for Pentium 4, the hourly rate is 40 rupees per hour. Let's say I need to change it to 50. We need to make sure that the corresponding rate is changed for all the students who are working on that system. You understand? If I update this table saying that update this table where hourly rate for Pentium 4 is 40. So I need to change this 40 to 50 for roll number 103, for roll number 106, for roll number 107. I'll have to run the update query thrice. I have to change this to 50, this to 50, and this to 50. So I'll run the update query thrice. Update table student system charge set hourly rate is equal to 50 where roll number equal to 103. I'll repeat this query again with a condition where roll number is equal to 106. Again where roll number is equal to 107. That's a hassle for me. That is causing a trouble because I have to update 3 rows and I have to run the query thrice. That doesn't make sense. That's an update anomaly. Consider a situation if I had system use and hourly rate as a separate table. Fine. I have to update just once saying that update so and so table where system used is Pentium 4. It will update the entire table with only 2 columns which have system use and hourly rate. There would be delete anomaly as well. This type of anomaly occurs whenever we delete the tuple of student or we delete a student who happens to be only one student left which is working on a particular student system. Imagine a situation at one point of time. So I have roll number 100 Abhi, system P4, hourly rate 40. He worked for 7 hours. Suppose in my computer lab I have at that point of time I have just one student who is working. So my database would say 100 Abhi P4 40 hours and 40. Now something comes up and I have to discontinue my Pentium 4 systems. So I am updating this table. I would delete this row where the system used is P4. Now, once I delete that row, I won't have any record of Pentium 4 system in my database. Let's say 101 oven P2 47. So, let's say at one point of time, I have these much people I have this much set of students. Okay, fine. One fine day, these students completed their course and they went off. One fine day, these students completed their course and they went off. Just understand what I am doing. So, when student E left the course, he graduated or something, his record would be deleted from my system. When I am deleting this record, my record for processor 5 with 40 hours a rate is also gone. I don't have any record, though I have that system in my computer lab. But that record is gone, it's vanished. That's a delete anomaly. Consider a situation I had this as a separate table, this as a separate table. So if I need to add a student, I can add over here. If I need to add a system, I can add over here. If some system goes off from my computer lab, I'll remove that system. This won't affect my student table. This will just update my this table. But when we had everything together, if a student graduates, this will be gone. My system P5 or system number 5, I won't have any record to update for it. I don't have anything. I don't have anything that would say that yes, I had system 5 in my computer lab. If I don't have anything designed like this, a separate table, so that is a delete anomaly. My data is lost. If I delete something, I don't have anything to save that data. So that is a delete anomaly that we are talking about here. This type of anomaly occurs whenever we delete a student who happens to be the only student left which is working on a particular system. In that case, we will also lose the information about the rate that we charge for that particular student. So, my second normal form still has certain errors, certain anomalies that need to be worked on. For that, we come on to the third normal form that we would be discussing tomorrow. And let me just stop the recording, and I have to discuss something with you guys.